Welcome back to the Kids Book of Weather Forecasting. This will be the second chapter. It is entitled The Atmosphere and Ocean of Air. Okay, hold your breath for this important announcement. You are at the bottom of an ocean of air, that is. Yes, the air you breathe is a lot like an ocean that surrounds the Earth. We call this ocean of air the atmosphere. Not only does it provide the oxygen we need to breathe, but it protects us from the harsh environment of outer space. The weather is like a huge machine that cranks out wind and rain, spins up storms, and pushes the clouds along to give us clear, sunny skies. Think of the atmosphere as the engine that runs this machine. Barely aware of air. When you need to breathe, do you go looking for air? Of course not. It's just all around us. You might even forget that it's there. This stuff we call air is thinner and lighter than water. Can you see air? Not exactly, but you can see the effects of air. Blow into a bag and quickly close the top. Could you flatten that bag without letting the air out? Although it's invisible, air has weight and takes up space, so it pushes out the sides of the bag. Just how much air is up there? Well, the air is topless, without a ceiling. The outer edge of the atmosphere blends into space about 1,000 miles above Earth, where there is no air. What keeps the atmosphere from just drifting away into outer space? The same force that holds us here on Earth, gravity. Gravity is what gives everything, including us, its weight. The closer we go to Earth, the stronger the force of gravity pulling us down. Think about what happens to the astronauts when they get outside the pull of Earth's gravity. The pressure is on. Using a sharp pencil or a nail, have a grown-up help you poke 3 holes in the side of an empty half-a-gallon, 2-liter cardboard milk carton. Holding the carton over the sink, fill it with water and watch how it leaks out the holes. Does each stream of water look the same? More water, so more weight, is pressing on the bottom hole, so the straightest stream is from the bottom hole. The water barely comes out the top hole because only a little water is pressing on top of the water leaking out. It works the same way as air. The air closest to the Earth has the weight of all of the air above it pressing it down. This force is called air pressure. The farther you go up into the atmosphere, the less air pressure there is because there's less and less air above it pushing it down. One strong kid. Does it seem funny to think of air weighing something? After all, we don't have to push it out of the way when we walk around. Well, not only does air have weight, but if we're at the bottom of this ocean, where is most of the air? On top of us. Put a sheet of notebook paper on the ground. Can you guess how much an amount of air that size would weigh? Don't forget that air rises up in a column to the end of the atmosphere. It weighs a whopping 1,293 pounds. So why doesn't it feel as if a herd of elephants is sitting on top of you? Your body is designed to handle the weight of the air. The pressure on the inside of your body, pushing out, adjusts to the pressure on the outside, pushing in. So they are equal. Now that's impressive. What kind of weather puts the pressure on when you're on the job? My biggest challenge is when the weather is changing quickly, a line of dangerous thunderstorms forming rapidly on a summer afternoon. For example, quickly responding and informing people of what may happen and how best to prepare can really be a matter of life or death. Here in New England in the United States, winter weather really keeps me on my toes. Oftentimes, it will be snowing in one area, yet only a few miles away, freezing rain is falling instead. I have to be sure people are prepared for the conditions before they find themselves in a dangerous weather situation. That's the Ask Mark selection. Recorded in history, weather and war. Weather has often taken center stage in history, determining the outcome of major wars like the American Revolution. General George Washington and his troops surprised the British by crossing the ice-choked Delaware River at midnight in December 1776. When the American forces reached the other side, they successfully struck enemy camps in Trenton, New Jersey, weakening the British Army. When Washington's troops camped at Valley Forge in Pennsylvania the following winter, they lacked the clothing and shelter necessary to spend the winter outside, and 2,000 of the 12,000 soldiers died. Just when it was beginning to look hopeless, the Americans rallied against the harsh weather. Additional supplies and equipment were sent to the camp, and the American forces went on to win many battles and the war. Ask Mark, what's the funniest weather saying you have ever heard? If ice in November will bear a duck, nothing comes after but sleet and muck. I think ducks and muck are both funny, so it just sounds silly. However, the prediction is actually a pretty good one. Weather tends to go in cycles of cold, warm, cold, etc. So if the weather is cold enough in November to freeze the ponds, thick enough to hold up a duck, then the weather that follows in winter will be warmer than usual, sleet and muck. Weather watchers, Galileo Galilei. In 1593, the Italian scientist Galileo developed one of the earliest thermometers. He was also the first person to show that air has weight by inventing a device called a thermoscope, used to measure the pressure of the atmosphere on water. His pupil, Evangelista Torricelli, substituted mercury for the water and made the first barometer in 1643. Meteorologists use a barometer to measure changes in the air pressure, also called barometric pressure. A liquid barometer has a tube filled with mercury and looks something like a thermometer. As the air pressure rises, it pushes the mercury up. An aneroid, without liquid, barometer has a small airless container with a movable side. A pointer or needle attached to the movable side shows the changing barometric pressure by moving up and down as the air pressure outside the container decreases and increases. Your basic aneroid barometer. Next, you're going to make a barometer. With tons and tons of air moving around all the time, a barometer is one of the most important tools meteorologists use to predict changes in the weather. You can make a simple version of an aneroid barometer that really works. Here's what you'll need: petroleum jelly, empty can without top, balloon, rubber band, tape, drinking straw, light-colored poster board, and a marker. Here's what to do. Spread a thin layer of petroleum jelly around the edge of the can. Be careful not to cut yourself. Stretch the uninflated balloon over the can and seal it with a rubber band. Tape a straw into the middle of the balloon. Place a piece of folded poster board next to the can in a place where it won't be disturbed. Mark the end of the straw on the poster board. Check your barometer once or twice a day for a week and mark any changes in position. Label your highest mark high and your lowest mark low. Reading your barometer. Air pressure changes from day to day as weather systems travel over or near you. When air warms up, it gets lighter and rises. When this happens over an area of hundreds of miles, the state where you live, for example, there is less air pressing down on the balloon. The air inside the can pushes up, causing the end of the straw to move down, indicating that the air pressure is falling. Low pressure brings stormy weather. As air cools down, it becomes heavier and sinks, so more is pressing down on the balloon. How does this affect the straw? What does that tell you about the air pressure? What kind of weather do you think you should look for? Answer: the end of the straw is moving up, meaning the air pressure is rising. Look for clear skies. Be a meteorologist. Barometric ups and downs. In your weather log, record the position of the straw every day and then describe the weather. Do you notice any relationship between the position of the barometer and the weather? Clear and sunny? Overcast? On many liquid barometers, you'll find words describing the weather next to the column of mercury that records the air pressure. Lower pressure is often labeled stormy or rain, while high pressure is described as fair or dry. In between is generally labeled change. Try it. On your poster board, label the low pressure area rainy, the high pressure sunny, and in between change. Do your barometer readings always match the actual weather? Forecasters getting it right rules. When the barometric pressure is high, skies are fair, and it's a great day to be outside. When air pressure is falling, watch out. Wet or stormy weather is on the way. If the pressure is steady, as forecasters say, then no change in the weather is predicted. Try it. Here's an easy way to remember this point. Point your thumb in the direction that the barometer and the air pressure is changing. If the barometer is going up, the weather gets a thumbs up. If the pressure is falling, the weather gets a thumbs down, meaning stormy weather. Be a meteorologist. Choose your ballpark. You've won tickets to see the Chicago Cubs play the Colorado Rockies, and you get to choose whether to watch the game at Wrigley Field in Chicago or at Coors Field in Denver. You really want to see your favorite slugger hit a homer. The Denver game is tomorrow. The Chicago game is next week. It has been partly cloudy in both cities, and the barometer is steady. Chicago, only about 500 feet above sea level, and Denver's nickname is the Mile High City. In which stadium do you have a better chance of seeing the ball blasted out of the park? Hint, think about elevation and air pressure. Answer, root for your team in Denver. More baseballs make it over the fence in Denver than at lower elevations like Chicago. The air pressure in Denver, which is 1 mile above sea level, is lower than the pressure at lower elevations. This means there is a little less air to push through, so things like baseball can fly farther. And with a steady barometer, no major storms are brewing to threaten your favorite slugger's chances. Ask Mark. So when the weather forecaster says, look for a high pressure area to move in by Wednesday morning, that means Wednesday will be nice? Almost always. Then why not just say, look for a beautiful day on Wednesday? Well, air pressure is only one part of the weather. Other parts, like the temperature, the wind, and the humidity, may have different effects. Barometric pressure is a great measurement to start with, though. We'll add more tools and forecasting information in the next few chapters. Weather words. A large mass of low-pressure air is called a low. What do you think forecasters call a large area of high-pressure air? Answer. A large area of high-pressure air is called a high. Quick, take forecasts. It's a beautiful sunny morning, and you're planning a picnic for later in the day. You notice that your barometer is falling. Will it stay sunny? 2. Yesterday at 10 a.m., your thermometer read 42 degrees Fahrenheit, and today at 10 a.m. it reads 46 degrees Fahrenheit. What do you think your barometer is doing? Should you take your raincoat when you go out? Answers. 1. Not likely. Falling pressure often indicates a storm approaching. 2. Warmer, lighter air is starting to arrive, causing the air pressure to fall and the barometer to drop. This could mean rain, so grab your slicker. You're acting just like... Would people say you have a sunny disposition? Do two friends have a lot of ups and downs, like have a stormy relationship? Sometimes we use images of weather events to describe people. What do we say about someone who doesn't pay attention and is daydreaming? He has his head in the clouds. Ask Mark. Why does the sky look blue? Well, for starters, think about when it looks blue. It is blue. Is it blue when it's cloudy or raining? Is it blue at night? So our blue sky has something to do with sunlight. Put a mirror in a glass of water so the mirror is at an angle and facing the sun. Hold a piece of paper at a slant in front of the glass. Move the paper until 7 colors show up clearly on your paper. Recognize those colors? Although it appears to be white, or colorless, light is really made up of 7 visible colors. You use the mirror and the water to bend or refract the sunlight so it is separated into those 7 colors, called the spectrum. As a beam of sunlight travels through the atmosphere, most of the colors of the spectrum pass directly to Earth. Some of the blue light, however, hits particles of air and is scattered across the sky, making it look blue. Weather watchers. Lord John William Strutt Riley. This English scientist asked himself that same question. Why is the sky blue? He won the Nobel Prize in 1904 for discovering how light rays scatter when they pass through air, making the sky appear blue. Roy G. Biv. On a bright, sunny day, grab the garden hose. Standing with your back to the sun, spray a fine mist so that the sunlight shines right through the water. You made your own rainbow. What's more, you now know how that rainbow was created. When the sunlight bounces off the droplets of water, it is separated into the spectrum, and we see the colors of a rainbow. Red, orange, yellow, green, blue, indigo, and violet, or Roy G. Biv. Weather lore. Red sky at night, sailors delight. Red sky at morning, sailors take warning. Here's an excellent example of how making careful observations, the color of the sunset and the sunrise, and then connecting them to the type of weather that follows can be a reliable way of forecasting. People have been watching these natural events for thousands of years, and over time they noticed that the most colorful sunsets were followed by sunny, dry weather, good news for sailors, while a beautiful sunrise almost always came ahead of a storm. Sailors, be careful. This saying is true about 80% of the time, or 4 out of 5 days. Understanding percents. Percent comes from the Latin per centum, or in every 100. If we say this weather saying is true 80% of the time, we mean that it forecasts the weather correctly 80 out of 100 times. Not too bad. Meteorologists often use percentages to indicate the likelihood of the weather doing something. For example, they might say there's a 75% chance of showers tomorrow. Should you take your raincoat? You mean you're not sure? Science in the sky. Thanks to modern science, we now know that the red color at sunset or sunrise comes from the sun's spectrum. See page 29. At the beginning or end of the day, when the sun appears low in the sky, its rays pass through more of the dust and other small particles normally found in the atmosphere. These particles filter the sun's light, knocking out the violets, blues, and greens of the spectrum, but letting the yellows, oranges, and reds through. If we see a colorful sunset, then we can be sure there is dust in the air, and if there is dust, then it is not raining. Rain would wash away the dust particles out of the air. Also, if we can see the sun setting, we know there are not many clouds, so we can pretty safely say the weather to the west is dry and pleasant. Over the centuries, weather watchers have noticed that most weather systems come from the west and move toward the east, so tomorrow's weather should be a sailor's delight. Red skies in the morning mean the delightful weather is already to the east of you and moving away. This nice weather is most often followed by stormy weather, which is why red sky at morning, sailors take warning. When the sun is low on the horizon, its light must travel further through the atmosphere than during the day when the sun is right overhead, dust and other small particles. Thanks for reading today.